Hello and welcome to the latest in the Wall of Tennis series of Tech Talks, where we discuss how we can improve both system and workflow efficiency. Today we are going to be diving into the benefits to and selection of Bell & Gossett ECM pumps and how to figure out if they're a good fit for your particular application. We'll touch on what the benefits of the ECM motors are, also the limitations, what models of B&G pumps you can get with ECM motors, potential and real-world savings that you can experience, and how they tie into mechanical and domestic water systems. Start off by discussing the pluses and the drawbacks of ECM motors for pumping applications. By now we know what ECM motors are and how they differ from PSC motors. We know they're more efficient. How much more efficient? Turns out 30 to 40% more efficient, not exactly an insignificant number. We can have true variable speed in single phase operation, where standalone VFDs in single phase are not readily available. Quieter, kind of self-explanatory. What do we mean by easier to install? We limit the number of electrical connections and wiring versus a standalone pump with a remote mounted VFD. Cooler, the more efficient the motor is, obviously the less of its work is turned into heat. Helps longevity of the motor itself. The motors themselves are 25 to 35% lighter than a PSC. Now, that's not much of a difference when we're talking about a fractional horsepower motor, but as we get into the larger sizes now and in the future, this will have a greater impact. As far as drawbacks, increased cost. That is true, but we will touch on this a little bit more as we get a little bit deeper into the presentation. And currently, a real limitation in applying ECM motors is really the limited horsepower offerings that are out there. So let's explore a little bit on the offerings that B&G has with ECM motors, the various pumps that are available with ECM motors. We'll start off with the E90 and the E60 series. A lot of you are familiar with the 90 and 60 series inline pumps, real workhorses in the pumping world. For half horsepower and single horsepower, single phase applications, you can get them with ECM motors. While that can seem like a very specific application, it does offer you true variable speed control of the pump. So it's a direct linear speed control between 300 RPM and 1750 RPM. You can control this two ways, one being a physical knob, an onboard potentiometer, where you would turn to adjust the speed of the pump, and second being 0 to 10 VDC. So you can tie in with your BMS system in order to control the flow of the pump. And obviously we're in cast iron and all bronze construction, same as the regular 60 and 90 series. So these are good for mechanical and domestic water applications, mechanical system and domestic water applications. Here's where we're going to spend a bit more time. The ecocirc XL, the B&G ecocirc XL. This pump combines a high efficiency ECM motor with an intelligent controller. The controller on this pump is capable of a lot more really than a standalone VFD is. You can get this in a variety of horsepowers, obviously fractional up to 3 horsepower. The model designations for an ecocirc will be ecocirc and then two numbers separated by a dash. That first number is going to be your max head. And then that second number is going to be your max flow. Now, that is not a max flow at that head. This is limitations of flow and head. Pump affinity laws still apply, so there is still a curve. Now you can see we have a number of different options in single and three phase, so we can cover both high flow and high head. And due to the variable speed nature and the control of the controller, you have the ability to cover a lot of ground with a given pump in flow and head applications. As far as Modbus, BACnet, and wireless integration, all of this happens directly from the onboard controller. Now, if you're going to control the pump wirelessly or through its own network, that does require a separate card. Next, we'll explore the control strategies available on every ecocirc XL. Out of the box, we have the ability to control the pump and therefore the performance of that pump using all of the control strategies that you see here. Constant speed, same as a PSC motor. Constant pressure. Basically, you would set your differential pressure, and the controls within the drive on the pump would adjust the flow accordingly. Proportional pressure. Pump responds to that decrease or a decrease in flow by reducing the pumping head. Moving over to the top right, set point temperature. So this is you would establish a nominal differential pressure within the system, and then you control that differential pressure via the fluid temperature. So as your temperature goes up or down, the pump recognizes with that onboard temperature sensor, to maintain that differential pressure. The next set point temperature, the pump can actually, with its onboard sensor, maintain a constant temperature within the system. And then moving down to differential temperature, this mode does actually require an additional sensor or an aquastat. It maintains a constant delta T between the pump sensor, the onboard pump sensor, and that external sensor. So you can see that there's a number of ways out of the box that you can configure the pump in order to meet your specific application demands. Next, we're going to move on to the savings opportunities. Now, this chart, this breakdown here refers to the contractor savings. This is a real application of a job that we did recently with a ecocirc XL versus a traditional 90 series, traditional three-phase 90 series with a remote mounted VFD. You can see that the material cost is definitely more for the ecocirc XM up front. Pump install, little bit of variance in real life, but for all intents and purposes, even the amount of time to mount just the pump versus just the pump of a 90 series versus an ecocirc. The VFD, here's where we start to diverge with the additional installation requirements. Obviously, you need space on the wall for the VFD, all the additional equipment, and fasteners, junction box wire, unistrut, all of that. And possibly, depending on how you're set up, a whole other trade to wire in the VFD. But the big one that really can have the most effect here is that last thing in that box is the coordination. This is your project manager's time or your time if you are the project manager, of your time and your effort to coordinate all of this, especially if you do require another trade to come in. And this is just one pump. I mean, imagine if there are additional pumps on the job. So, I mean, we see that we do end up being less than a regular PSC motor with a drive. But again, one application, one pump, and that coordination doesn't necessarily, you don't get to amortize your coordination effort just because you have more pumps. So the savings can be real and can be justifiable for making that switch to an ecocirc with an onboard drive. And next we'll discuss the potential for owner savings, and sometimes it's the ability to convince the owner that they need to spend a little bit more money up front in order to get a more efficient system. Everyone has seen a version of this bin graph. This heating system reflects an on-off or a constant circulation pump with that black line, a PSC pump with that black line, and a variable speed ECM pump with the pink line. Now, granted, these pumps tend to be low or fractional horsepower, but there can be a lot of them, so that can be real money for the owner with regards to energy consumption. And also the variable speed nature tends to lend to the overall comfort. We touched on the controls, whether it's the system control with the various delta T's and delta P's and how we control the actual flow, or the pump control being with BACnet, Modbus, or wireless operation. Space savings, no VFDs and wiring on the walls. This can contribute to additional space and additional, especially with how tight mechanical rooms are nowadays and getting tighter by the tighter by the day. And then finally, we discussed it earlier, the ecocirc can cover a large flow and head range very efficiently. So this can limit the number of pump models that you actually have to keep in stock and or manage. This is usually of great interest to industrial and OEM customers that are managing their own pumps and maintenance on the inside, not necessarily calling the service contractor for every little thing. So this can be a big benefit to the on-site maintenance crews. Next, we'll touch on where the ecocirc XL and the E90 and E60 series ECM pumps can be applied and then integrated into the system. Obviously, on smaller systems, chilled condenser, hot water, they can be used as the primary or the system pump within a piping system. And then on the larger systems, they really can be paired with other high efficiency equipment, especially on a primary secondary system, whether it's condensing or non-condensing, you still have the ability to increase the efficiency or contribute to the efficiency of your system by having a more efficient pump in the network. And then also domestic water pumps. All of our Lochinvar armors come with an ECM pump for standard applications. And then we can also use ECM pumps, the smaller circulators, for kind of the standard stuff of recirculation and freeze protection. So You can reach out to Wallace Ennis, New York, or New Jersey offices with any questions that you might have regarding ECM pumps or any of our other product lines for information on application, selection, or specific projects. Thank you for watching, and continue to tune in for further product and application seminars.